All right, so we're going to talk about the calculator portion of the mid-chapter 6 test. One of the things that'll be on that is the transformations. Write a function g that is a reflection in the x-axis and a horizontal stretch factor of 2, followed by a horizontal translation right 1. So this is going to start with reflection in the x-axis, that's negative f of x on f of x equals 4 to the x. So that's negative 4 to the x, or you could do negative parentheses 4 to the x, up to you. Just know that that negative is not getting raised to the power. The next is a horizontal stretch factor of 2, that's f of 1/2 x. As a horizontal stretch, reciprocal is what goes into the equation 1/2, and that is negative 4 to the 1/2 x. So we replace the x with 1/2 x. And then lastly, a horizontal translation right 1, that's f of x minus 1. So that's negative 4 to the 1/2, and I replace the x with x minus 1, and we distribute. So we get g of x, the final answer, is negative 4 to the 1/2 x minus 1/2. And we'll just leave it like that. That's your answer. Okay. Number 31. Write a function g that is a vertical stretch factor of 3 and a horizontal translation to the left 5, followed by a vertical translation up 6 of e to the x. So the first vertical stretch factor of 3 is 3 f of x, which is 3 e to the x, 3 times e to the x. Horizontal translation to the left 5, that's f of x plus 5. It's opposite with horizontals. And so that is 3e to the x plus 5. There's no coefficient on the x, so I don't have to distribute anything, but I'm really just replacing the x with that x plus 5. And then a vertical translation up 6, that's f of x plus 6. So that's 3e to the x plus 5, and then plus 6. And that's your final answer. Let's move this up a little bit. Number 32. Oops. Write a function that is a reflection in the y-axis, followed by a horizontal shrink factor of 1/3 and a vertical translation down 7 of the log 3 of x. So reflection in the y-axis is f of negative x. So that becomes the log base 3 of negative x. Then a horizontal shrink factor of 1/3 is f of 3x. Remember, horizontal is the reciprocal. And so that's the log base 3 of negative times the 3x. I'm replacing the x. The negative multiplies. Log 3 of negative 3x. And then lastly, a vertical translation down 7. That's f of x minus 7, which is log base 3 of negative 3x minus 7. That minus 7 should be outside the parentheses. If it was inside, that would be horizontal. And then the last one, make some room here. Let's erase this one. I'll do 33 up here. Write a function that is a vertical translation down 4, followed by a reflection in the x-axis. Oops, wrong color. reflection in the x-axis, and then a horizontal translation, right 1 of the graph of the natural log of x. So vertical translation down 4 is f of x minus 4. So that's the natural log of x minus 4. The next one is a reflection in the x-axis. That's negative f of x. So that's negative times the natural log of x minus 4. That negative is going to flip it. Remember, if it flips from negative 4 over the x-axis, it's going to go up to positive 4. So it becomes negative natural log of x plus 4. And then lastly, a horizontal translation to the right 1. That's f of x minus 1, which is negative natural log of x minus 1 in parentheses, and then the plus 4 outside the parentheses. And that's your final answer there. Okay, so number 42. A popular YouTube creator has 100 subscribers. Each of those subscribers get 2 of their friends to subscribe to the channel every day. Create a t-table that shows the total number of subscribers up to 5 days. Don't forget to label your table with meaning. So that means our table is going to be days and then total subscribers. So day 0, there is 100 subscribers. Each of those 100 people get 2 more people to subscribe. So that for each person, that includes themselves and another subscriber. So that's 3 subscribers total for each of the original, which makes day 1 300 subscribers. And then each of those 3 get 2 more, and these give 2 more, and this one gets 2 more. Now we have a total of 3, 6, 9, and then there's 100, so that's 900 on day 2. So we can see our growth factor is 3. 2,700 by day 3. Day 4 is 8,100, and day 5 is 243. So the growth factor down here, part E, is 3, because we are increasing our table is multiplying by 3 every time. And that makes the rate of growth, of increase, that the fact that they are adding 2 subscribers per day. So the rate of increase, or the growth rate, is 2. So that takes care of A, E, and F. As we look at the rest of these, we want to know how many days it would take for 100,000 subscribers. So what would day 6 be? So 243 is going to be 729, and then times 3. Okay, so that's just with multiplying by 3 with my calculator. So we can see that 100,000 is somewhere between day 6 and 7. So to get more accurate, we probably want to write our equation first. Remember that our equation is A, the initial, times B, the growth factor, to the x power. And that helps us answer part C, y equals our initial 100 times our growth factor, which was 3, to the x power, or t, however you want to write it. And we're going to try to figure out somewhere between day 6 and 7 when it gets to 100,000. So 100, I'm going to do this in my calculator, times 3 to the, let's try 6.5. Halfway between gives me 126,000. So 100 times 3 to the 6.5 is 126,266. So that's higher, so I'm going to go down a little bit. I'm going to try 100 times 3 to the 6.3. In your calculator, you're just going to change the decimal point till you get closer and closer. This is 101,359. So I'm going to try 6.25. Just .25 is 95,941. So let's try 27 maybe. 98,000. I'm gonna try 28. 99,000. Try 29. So if I do x equals 6.29, okay, on the test you want to write out a couple of the ones that you're trying. I know that you're guessing and checking in the calculator, but we have 100,251. That's going to be close enough because that's our two decimal places. So we're at 6.29 days. And then we can plug in 10 to answer the last question. We get so 5,904,900. So basically that's all I need. I need every one of you to get 2 people every day to subscribe to my channel, and then I can be famous. Just kidding, guys. All right, number 43. What if 22,000 people are infected and a cure was found? The antivirus would cure 1/4 of the people per day. So that is going to be our rate of decrease. So let's kind of break apart some of this important information. The fact that 1/4 of the people are cured each day is our rate of decrease. So we'll put that down here, or 0.25. And then our decay factor, B, is 1 minus 0.25, which is 0.75. So we're starting at day 0, and there's 22,000, and that's number infected, and this is days. So don't forget to label your table on the test. So day 1, 1/4 of 22,000 is 5,500. Now this is the most common mistake on these problems, is that we put 5,500 into the table, and that's not how many are left infected. This is how many got cured on day 1. So we have to do 2,200 minus 5,500. I'm sorry, 22,000. Insert that extra 0. And we have 16,500 that are still infected. So 22,000 minus 5,500 gives us the 16,500. And then we would do that process again, times 1/4, and then subtract, that's 4125. Again, this is how many are cured. So we have to take 16,500 minus 4125, and that's 12,375 on day 2. But there has to be a better way, right? And the better way comes from the decay factor. If 1/4 of the people are cured each day, that means 75%, or 3/4, are still infected each day. So we could multiply instead by 0.75 to get the next number, and we cut out the whole subtracting thing. So that's a faster way to do that. And that's 9281.25. And a 4 times 0.75, 69,060.94. A 5,220.7. And that's our table for up to 5 days. And then it asks us in B how many are still infected on day 7. So really what we want to do here is we want to create a model so we can figure this out without having to continue a table. And remember that our model is A, B to the X. A is our initial, 22,000. B is our growth or decay factor. In this case, our decay factor is 0.75 to the T, and this is our model. Remember, the model is not a graph, the model is an equation. So y equals 22,000 times 0.75 to the T. And then that kind of helps us. Now I can plug that in and plug 7 into that. So let's plug in 7, 22,000 times 0.75 to the 7. And that's day 7, 29, 36, 65 people are still infected. And then part D, approximately how many days would it take for all 22,000 people to be cured to 2 decimal places? So that's where I know it's 2,000 on day 7, so maybe let's take that same equation and try 10 days. Day 10, there's 12,038. Let's try day 15. There's 293. And let's try day 20. 69 on day 20. Let's try day 25. And I'm just, with my calculator, continuing this pattern. And you want to write down your work. So write down the things you've tried. How about 28? I'm at 16. 28 is at 6. So let's try 30. 30 is 3. Let's try 35.9. That's less than 1. I can get a little bit. 35 point, let's try 37. Let's get close to 0. Now this is never going to actually equal 0, so as we get closer and closer, we can say at 37 days, I have 0.5 of a person cured, and that should be sufficient. All right, Jack and Jill are twins. Jack invests $6,250 at a rate of 6% compounded daily. Jill's investment data is shown in the graph below. How much did each person invest initially? At 7 years, who has the higher account balance? And show your work to support your claim. So let's look at, this is Jill's investment data. Her initial amount deposited is there, which is just over $4,000. So Jack invested more. And this is called your principal. Sorry for my bad handwriting. So this is called your principal. So who had the most principal? It was Jack here. Now we need to write an equation for Jack. A times 1 plus R over N to the NT. I'm sorry, it's P equals A. So his principal is 6,250. 1 plus 6% as his interest rate is 0.06. Compounded daily, so that's 365 to the 365 times T. This is the equation for Jack. We can simplify this a little bit. This is 6250 and 0.06 divided by 365 plus 1 is 1.000. We got to get all those so it's not just 1. And 365 to the 7th power. So we're going to raise that 1.00016 to the 7th power. 7 times 365. So if you're doing that whole thing in your calculator, make sure you put the 365 times 7 in parentheses. And so $6,250, 1.5219 times 6,250. Jack has $9,511.93 after 7 years. And after 7 years, it looks like Jill has, this is about there, under $9,000. So Jack has more after 7 years. Cody bought a $35,000 car. The bank loaned him a simple interest loan for 6 years with a monthly interest rate of 3%. How much did the loan cost him? How much money would he end up owing the bank at the end of 6 years? Or did he end up paying the bank at the end of 6 years? So his initial amount, remember our simple interest equation is interest is the principal times the rate times the time. And then we can add that to how much the car was. So the interest is the $35,000 times the rate, 0.03, times the time, 6 years. So that's 35,000 times 0.03 times 6. That's the interest is $6,300. So that's how much the loan costs you. The interest is what you are paying extra to have a loan instead of paying up front. And then how much money did he end up paying the bank by the end? $35,000 plus $6,300. My dog is being very restless right now. And that's $41,300. Okay, Shayla took out a Stafford unsubsidized college loan for $16,500 for 5 years that was compounded monthly. What is her balance at the end of 5 years if she made no payments and the interest rate of the loan is 5.6%? And what was the interest on the loan? So again, that's the equation we used on problem number 44. P times 1 plus R divided by N. We have to convert the yearly rate to a monthly rate, and R times T, we convert the time to months. So the 16,500 times 1 plus the rate is 5.6, so 0.056 divided by 12 monthly. And then it's, I'm sorry, this is NT, not RT. 12 months times 5 years. So that's 16,500 times 0.056 divided by 12 is 0.0046, so 1.00467 to the 60th power, because 12 times 5 is 60, and that's wait, hold on. I messed up in my calculator. I forgot to add the 1. So that's 1.322. And remember not to round in your calculator. You can round when you're writing it down on your paper to show your work. And you do need to show some work. Times 16,500 is $21,817.43. I'm going to round it. So that's how much she owes at the end of the 5 years. How much interest did she pay? We subtract off the principal, 16,500. And she paid interest of $5,317.43. Okay, Isaac invested $31,000 into a Roth IRA account at an annual interest rate of 6.25%. What is the balance of the account in 6 years if the investment was compounded quarterly? So quarterly is 4 times a year. Same equation, A equals P, 1 plus R over N to the NT. And that's 31,000. 1 plus 0.0625 divided by 4 to the 4 times 6 years. So 31,000 times 1 plus, well, I don't really need to put the plus, 1.015625 to the 24th power, raised to the 24th. 31,000 times 1.451. Again, I'm not rounding in the calculator. I'm just continuing to do the operations. I'm adding 1. Then I'm raising that answer to the 24th power. Then I'm taking that full answer without rounding and multiplying it by 31,000. And I get $44,974.14 is how much is in his account after 6 years. Number 48, the EHS farm initially had 1,024 cows. They sold the cows at a rate of 3/4 of them per year. Write a model that represents how many cows are left at the farm per year. So that's, again, same idea. A y equals 1 minus r to the t. So this is our decay, exponential decay formula. A is the initial amount, 1,024 cows, 1 minus 3/4 to the t, which is 1,024 times 1/4 to the t, and that's your model. Or you could write it, why do we keep doing that? 24, and you could write it as 0.25 to the t if you wanted, equals y. Make a table to show the number of cows on the farm for the next 4 years. So let me make a little space over here. Let's see. So it's the year and the cows. So on year 0, we have 1,024 cows. And we sell off 3/4 of them. That means we are keeping to 1/4 of them, so 0.25. 0.25 of 1,024 is 256. This next year, 1/4 of 256 is 64. The next year, 1/4 of 64 is 16. And year 4, 1/4 of the 16 is 4. How many cows were on the farm in 3 years? That would be 16. You can also find that by plugging 3 into the equation. Okay, a chemist places 5 bacteria in a petri dish each month. Each bacteria grows 3 new bacteria. Complete the table for the first 3 months. So let's look at the 1 bacteria. He creates 3 new ones. That's a total of 4. That's going to be your growth factor. Your growth rate is the 3 that he's growing every month, but the factor is the 1 plus the rate, all of it. So the 1 plus the rate is the factor. So on our equation, I guess we could make a table. 0 months and bacteria. So there's 5 to start with. The growth factor is 4, so they multiply by 4 every time. So in 1 month there's 20. In 2 months there's 80. In 3 months there's 320. In 4 months there's 1,280. And then on month 5 there is 512. 5,120. I'll write a model for the number of bacteria. It's A, initial, B, your growth factor to the X, growth or decay factor, but in this case it's growth. So it's 5 times our growth factor was 4 to the X. So 5 times 4 to the X is our equation for B. How many bacteria will there be in 12 months? We're going to plug in 12, 5 times 4 to the 12th. And that's really large, 83,886,080, 83,886,080. And then about how many months will it take to have 524,280 bacteria? So we know it's between 5 and 12. Let's try like 7. So in my calculator, I'm going to do 5 times 4 to the 7th, let's say. So that's 81,920. 5 times 4 to the 9th. Let's try that 9th. 131,000, no, 1,310,720. So it's, we better try 8, because it's between 7 and 9. So 8 is 327,680. So we're getting a little bit closer. We want 5,024.28. So let's try 8.5. And we're going to try 8.5. 5 times 4 to the 8.5. I'm at 655,360, so I need to go smaller. So let's try 8.4. Actually, let's try 8.3. 8.3 was 49,670, and so we need to go smaller. 8.2 is still 400,000. Oh, wait, I need to go a little bit higher. I'm sorry. 8.3 was 496,000. I'm sorry, I need to go higher than that. So I'm going to try 8.35. I got 532,317. So in my calculator, I'm going to change it to 8.34. And I got 524,989. So let's go to 8.33. And that's between, so that's under, so 5.3, so 8.34 is going to be your answer, because 8.33 is under it. It's 517,761, and 8.34 was 524,989. So I would have to get more decimal places, and we just wanted to do 2 decimal places is fine. So here we are close enough with 8.34 months. Okay, so let's kind of just erase all this stuff so we can have room for this problem. There were 6,000 car accidents last year. If the number of car accidents increase each year at a rate of 18%, write a model that represents the number of car accidents for each year. So y equals our initial 6,000 times 1 plus the rate 0.18 to the t. And that's 6,000 times 1.18 to the t. So that's A, your model, and B, how many car accidents in 4 years. So y equals 6,000, 1.18 to the 6, I'm sorry, to the 4. So 6,000 times 1.18 to the 4th power is 11,632.67. Okay, last problem. There were 5,000 fish in a pond. Because of water pollution, the fish started dying at a yearly rate of 13%. Write a model that represents the fish in the pond per year. So that's, again, y equals 5,000 times 1 minus, because they're dying off, so it's getting smaller, 0.13 to the t. And so that's 5,000 times 0.87 to the t power equals y. What is the decay factor? The decay factor is 0.87. The decay rate, I'm sorry, this is your factor, 0.87. The decay rate was at a rate of 0.13. So that answers D, 0.13 or 13%. How many fish are in the pond after 3 years? Plug it in the calculator, 5,000. I can't see my calculator, it's really dark. Times 0.87 to the 3rd power. And that's C, 32, 92, 52. So that's our exact number. We should probably round that and say there's about 3,292, because you can't have a half a fish really. How many years will it take for the pond to have about 1,500 fish? So we're going to take our model and we're going to do that whole guess and check thing. So I'm going to try 5 years. In 5 years was 2492. So I'll try 7 years. 7 years was 1886. Try 8 years is 1641. And 9 years is 1427. So somewhere in between 9 and 8 years it happened, the 1500. So let's try 8.5. It's getting really close. 8.5 is 1530. Let's add a let's go 48. 8.48. No, I need to go bigger. Because 8.48 was 1534, so that actually got larger. And it's decaying, so I need to make my number bigger. So 18.53. It's 1524. 18.55 is 1520. 18.57 is 15.15, 18.58, and 18.59 is 1511. 18.6. 61. 61 is 1507, 62, 1505, 65, 1499, 64 is 1501. So it's somewhere between 8.64 and then that gave me 1501. So you're just in your calculator checking it till you get close. When I did 8.65, I got 1499.03. So right there, it's somewhere between those two. All right, guys, remember your equations. Have our simple interest. I equals P times R times T. We have our compound interest, where A equals P times 1 plus R over N to the N times T. N is the number of times it's compounded. We have exponential growth, which is Y equals A 1 plus R to the T. And then we have decay, which is A times 1 minus R to the T. And then you have compound continuously, A equals P e to the RT power. So make sure you have these memorized.